Lakana, good morning to all. Today I am going to discuss about the topic on finite element analysis. What is meant by finite element analysis? Any idea? What is meant by FEA? FEA, finite element analysis. Okay, it is one of the analyzing software by using solve the structural problems. Okay, it is an analyzing techniques to solve the structural problems. Once you have to design any kind of product by using the CAD software, once you have to completed the design means you can use that any one of the analyzing softwares like either ANSYS or ANSYS or Nastran. N number of ANSYS softwares, analyzing softwares are available. Okay, you are in this semester you are going to study about the finite element analysis. Okay, it is an numerical method to solve the structural or unstructural problems. Okay, there are three types of finite element techniques available. First, this is the general computational methods we have to follow in our finite element method. Okay, first one is for ideation, and second one is for discretization, and third one is for solution. Either you have to choose the software or by using practical method you have to solve these design problems. Okay, then first one is for physical system. You have to form and design by using the CAD or any solid edge or SolidWorks, any kind of design softwares. You have to develop the physical modeling system. After that you are going for an analyzing by using the ANSYS software. Here we are using the ANSYS 14.0 FEA, finite element analysis, and ANSYS 14.0 mechanical product launcher may be used as an software, ANSYS software. Okay, then second one is for discretization. Discretization means you have to convert or slicing the component into n number of smaller components. Like for example, if we are taking this rectangular box or square box, how we are subdividing these elements? Any idea? Divide pannu. How we are discretization this square? We have to slicing this n number of elements, like so corner point is called node point, and combination of this node is called element. So discretization means first you have to slicing the whole product into n number of smaller division. After that only you have to easily analyzing that product is okay or not. Okay, this is the first step. If we are taking this L section as a finite element problem, first the finite element method is already I told it is a numerical procedure to solve either structural or unstructural problems. Okay, you have to take this L section. Okay, first this method involves the modeling the structure using a finite number of smaller interconnected elements. For example, this L section may be missing this 20 elements, like this is element number 1, 2, 3, 4, 5, 6, 7. First you have to analyze that small part only. After that finally we have to convert it into the small portion may be converted into entire portion. Finally we have to calculate the maximum stress strain acting that particular portion, like L section. Here L section, the point load, maximum load is applied here. This is the general FEA procedure, finite element procedure to solve the structural problems. First one is for noding. First one is for discretization. Then second one is for numbering of nodes and elements. Combination of nodes are called known as elements. After that we have to select the element type. Either we have to select that truss problem means we have to select that truss element, or beam problem means already you have to study the SOM, like n number of beams are available, like fixed beam and simply supported overhanging beam. If you are selecting that beam problem means you have to select that beam as an element, or otherwise truss problem means you have to select that cell or truss as an element. Okay. Then second is for select the displacement function. Displacement function means displacement formulas we are having. F is equal to K into U, which means F means force vector and K means stiffness matrix value, and U K into U means displacement vector. Finally we have to calculate that displacement values, like initially the boundary values may be fixed, like the simply supported beam means the first node may be fixed. After that second node we are applying either point load or UDL or UVL, any kind of load may be applied. Finally we have to calculate the displacement value. Is it correct? So in that FEA we have to calculate that stress, strain or maximum load withstanding capacity of that particular beam or point load. Okay. Then next step is for define the stress strain relationship. By using these relations like du by dx we can calculate that simple stress strain relationship matrix. Okay. Then next we have to derive the first we have to calculate the displacement or finite element equation for a single element. Then we have to consolidate that. Finally we have to find out the whole matrix, like we have to, same already I told, F is equal to K into U. F means force vector, what are all the load acting on that particular body, and K means we have to calculate the stiffness matrix, and U means displacement vector. Finally we have to find out the unnamed displacement value, as well as we have to calculate the stress strain of that particular problems by using finite element techniques. Okay. I already told, assemble the global stiffness matrix. You have to assemble that individual element matrix. We have to obtain that global stiffness matrix. From that global stiffness matrix we have to apply the boundary conditions, like what are all the boundary may be arrested, like 0 degrees of freedom, and what are all the loads applied, either point load or UVL or UDL, what kind of load acting on that particular portions we have to identify. After that solve the obtained nodal displacement means we have to find out the unknown displacement values, like we are applying that load on that particular place, how much withstanding that load or how much displacement will be taken care, which may be calculated by using that either stress strain of the unknown displacement values. Then finally we have to calculate that element stress strain values. Finally we can calculate that the pre-processing results, how we are in your software pre-processor and post-processor. Finally we have to obtain that solution in nodal solutions. Okay. In that procedure only we have to solve our finite element problems. Okay.